Every second you experience might be a complete fabrication of your mind. Modern physics reveals a startling possibility that time as we feel it, flowing from past to future, may not be a fundamental part of the universe at all. This idea challenges everything we know, from how we plan our days to our deepest understanding of reality. What if the past, present, and future all exist simultaneously? How would that transform the meaning of your life? We are about to journey through Einstein's relativity, the strange rules of quantum mechanics, and the latest theories that suggest time itself could be an illusion. By the end, you will see the fabric of reality in a completely new way. We will explore why clocks tick but time might not pass, and whether your memories are just fragments in a timeless cosmos. What does it truly mean to live in the now if now is not what it seems? Watch the second hand on a clock as it ticks from one mark to the next. It appears to glide in a smooth, unbroken circle. But that is a trick of your mind. Neuroscience reveals that your brain does not experience time as a continuous river. Instead, it takes snapshots, discrete moments of perception, and stitches them together to create the feeling of flow, much like a film projector uses individual frames to create the illusion of motion. Your conscious experience of a seamless present is a carefully constructed edit. The physicist Carlo Rovelli put it this way: time is not what we think it is. It is a layered, complex phenomenon that emerges from our ignorance. Your brain is not a passive recorder of time's passage. It is an active editor, and its decisions are influenced by everything you do. Cognitive psychology shows that your sense of duration is incredibly malleable, warped by your focus, your emotional state, and even the culture you grew up in. Think about how an hour spent with good friends can feel like a fleeting minute, while a single minute waiting in a long, slow line can feel like an hour. This is not time itself speeding up or slowing down. It is your internal clock being manipulated by your brain's processing. So if the steady flow of time is just a convincing story our brains tell us, a useful illusion for navigating the world, what is truly happening in the universe beyond our perception? To find that answer, we must look beyond the mind and into the fundamental laws of physics themselves. The man who would shatter our intuitive understanding of time was a patent clerk who loved to conduct thought experiments with trains. Albert Einstein asked a simple, world-bending question. What would happen if you were standing still next to a railroad track and you saw two bolts of lightning strike the front and back of a moving train at the exact same time? To you, the strikes are simultaneous, but to a person sitting in the exact center of that moving train, the light from the bolt at the front has less distance to travel to reach their eyes, while the light from the rear bolt has to catch up to the moving train. For that passenger, the two strikes would not appear to happen at the same time. This simple realization was the seed for his theory of special relativity, which declared there is no universal now. Your now and my now are not necessarily the same. It depends entirely on your motion relative to me. This relativity of simultaneity was just the beginning. Einstein showed that time itself stretches and compresses. A clock in motion relative to an observer will actually tick slower. This is not a mechanical error. It is time itself running at a different rate. The faster you move through space, the slower you move through time. This leads to the famous twin paradox. Imagine one twin stays on Earth while the other travels to a distant star at near light speed. Upon returning, the traveling twin would be significantly younger than the sibling they left behind. Their clocks, their biology, their entire experience of time's passage would have been fundamentally different. This forces physicists to view reality not as a three-dimensional stage where events unfold, but as a four-dimensional block where past, present, and future all exist at once, frozen together. In this block universe model, your birth, your life, and everything that will ever happen to you are all equally real, fixed points in the vast structure of space-time. We are like ants crawling along a single groove on a long, long vinyl record, only able to perceive the one point we are currently touching, while the entire song, from beginning to end, is already there. This is what led Einstein to write in a letter of condolence to the family of a deceased friend: "The distinction between past, present, and future is only a stubbornly persistent illusion." If he was right, then the relentless river of time we feel so deeply is not a feature of the universe. It might be a feature of us, a psychological artifact woven by our consciousness. But if time is not fundamental, what could possibly be creating such a powerful and universal illusion? To find that answer, we must venture into the even stranger domain of quantum mechanics. Einstein's block universe presents a profound puzzle, but the quantum world offers an even deeper strangeness. Here, the very rules of reality seem to rewrite themselves. A single electron is not confined to one place or one state. According to the principles of quantum mechanics, it can exist in a blur of multiple possibilities, a state known as superposition. It can be spinning up and spinning down at the same time, or exist in two places simultaneously until someone or something measures it. This act of observation forces the particle to choose a single, definite state from its cloud of maybes. This is the infamous measurement problem. The moment probability crystallizes into fact. This bizarre behavior extends to the phenomenon of quantum entanglement, where two particles can become linked across vast distances. Change the state of one, and its partner instantly responds, as if no space exists between them. In this spooky connection, information seems to travel faster than light, challenging our most basic notions of cause and effect. The sequence of events, the very bedrock of time's arrow, becomes fuzzy. If an effect can seemingly precede its cause, what does that say about the flow of time itself? The physicist John Wheeler offered a poetic summary of this confusion, suggesting time is what prevents everything from happening at once. Yet the mathematical equations governing these particles are often time-symmetric. They work perfectly whether you run them forward or backward. There is no inherent past or future built into the code of the universe at this scale. This stands in stark contrast to our everyday world, where an egg once scrambled never spontaneously unscrambles itself. To highlight this quantum weirdness, Erwin Schrödinger proposed his famous thought experiment. A cat is placed in a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, it triggers the counter, which breaks the vial and kills the cat. But since the atom is in a superposition of decayed and not decayed, the equations insist the cat must also be in a superposition, both alive and dead, until the box is opened and observed. This absurd scenario illustrates the profound conflict between the quantum realm and our classical experience of a single, definite reality unfolding in time. It forces us to ask if the flow of time is not a river at all, but something that emerges only when possibilities collapse into a single history. Is time a fundamental ingredient of the cosmos, or is it a secondary effect, a story that writes itself into existence only through interaction and observation? Our experience of time points relentlessly in one direction. We remember the past, but we cannot remember the future. A glass shatters on the floor, and its pieces never spontaneously fly back together to form a whole cup again. This one-way street of cause and effect is so fundamental to our reality that we rarely pause to question its origin. Why does time have an arrow? The answer to this profound puzzle appears to lie in a concept known as entropy. Entropy is essentially a measure of disorder, of randomness within a system. The second law of thermodynamics is one of the most robust principles in all of science, and it states that the total entropy of an isolated system always increases over time. Things tend to move from order to disorder, from structure to chaos. This is why your tidy room will inevitably become messy if you do not clean it, and why a hot cup of coffee will always cool down to room temperature, never spontaneously heat itself up. The physicist Arthur Eddington called this the arrow of time, declaring that entropy is what gives time its direction, but this only pushes the mystery one step further. Why was the entropy of the universe so incredibly low in the first place? All the arrows we experience, from the psychological arrow of our memories to the cosmological arrow of the universe's expansion, seem to be tied to this single, monumental fact. The universe began in a state of exquisite order, a highly organized, low-entropy state we call the Big Bang. From that singular moment of extreme order, the universe has been evolving, expanding, and dispersing, its entropy steadily increasing and creating the one-way flow of time we are all swept along by. If the fundamental laws of physics, like those in quantum mechanics, are time-symmetric and work just as well backwards as forwards, then the direction of time is not written into the laws themselves. It is written into the unique initial condition of our entire cosmos. The arrow of time may not be a fundamental feature of reality, but a cosmic accident, a relic of how our particular universe began. This forces us to confront a breathtaking possibility. If the flow of time is an emergent property, a story written by increasing disorder, then what does that say about the nature of existence before that first ordered moment? This cosmic arrow of time finds its origin in a single, explosive moment. Picture the entire universe, all matter, energy, and even space itself, compressed into an infinitely dense, unimaginably hot point. Then an expansion, a beginning. The Big Bang was not an explosion in space, but the very explosion of space, and with it, the ignition of time. According to our best measurements, this event occurred approximately 13.8 billion years ago. This is the moment our clock started ticking. The universe began in a state of exceptionally low entropy, a pristine order that has been unraveling ever since, creating the one-way flow we experience. But this presents a question that seems simple yet is profoundly meaningless within the framework of physics. What happened before the Big Bang? The renowned physicist Stephen Hawking offered a brilliant analogy to navigate this conceptual trap. Asking what happened before the Big Bang, he said, is like asking what is north of the North Pole. The question itself loses all meaning. At the North Pole, every direction is south. There is no more north. In the same way, the Big Bang may represent the ultimate North Pole for time. It is the boundary where time itself began. There is no before, because before requires time to exist. This idea is formalized in proposals like the no-boundary hypothesis, which suggests the universe is finite but has no edge or beginning, much like the surface of a sphere. You can travel across the surface of a sphere forever without ever falling off, yet it contains a finite area. In this view, time behaves like a dimension that gently curves back on itself. There is no violent singularity, no point of infinite density, just a smooth, closed geometry where the concept of a beginning vanishes. This leads to even more expansive theories like cosmic inflation and the multiverse. Perhaps our Big Bang was not the only one. Our entire universe, with its own arrow of time, could be just one bubble in a vast, timeless foam of universes, each with its own laws and its own beginning, or perhaps no beginning at all. In this grander picture, time may not be a fundamental feature of all existence. It could be a local phenomenon, a property unique to our particular cosmic bubble, a story our universe tells itself as it expands and cools. This forces a humbling thought. The relentless flow of seconds, hours, and years that defines our lives might be nothing more than a parochial detail, a footnote in a timeless multiverse reality. This philosophical conflict strikes at the very core of our reality. On one side is presentism, the intuitive belief that only the present moment is real. The past is gone, a collection of fading memories, and the future is not yet written, a realm of pure potential. It is the feeling you get when you are watching a live sports game, caught up in the electric tension of the now, where the outcome is still unknown. This feels true because it is how we experience the world. Yet, Einstein's relativity presents a formidable challenge to this view. That game you are watching live from your stationary seat on the couch is already over for someone else. An astronaut traveling away from Earth at a significant fraction of the speed of light would, according to the laws of physics, see your present as their past. The game would be a recorded event in their history. This relativity of simultaneity makes it impossible to define a universal present that everyone can agree on. How can the present be the only real thing if its definition depends entirely on how you are moving? This leads to the opposing view, Eternalism, which argues that past, present, and future are all equally real. They all exist, eternally fixed within the four-dimensional block universe. In this model, your fifth birthday is just as real as the moment you are experiencing right now, and your distant future is out there too, as fixed and unchangeable as a distant star. The philosopher J.M.E. McTaggart famously argued that time is an illusion because of the contradictions in how we order events. We place events in time using two series. The A series orders them as past, present, or future. The B series orders them using permanent relations like before and after. McTaggart pointed out that the A series is flawed because an event is constantly changing its property from future to present to past. But change requires time, so you need a second time to measure the change in the first, leading to an infinite and absurd regression. He concluded that the A series, the flow of time, is not real, and since time requires this flow, time itself must be unreal. This debate is not just academic wordplay. It has profound implications for our understanding of free will and destiny. If eternalism is true and the block universe is real, then your entire life is already laid out from beginning to end. It is like a pre-recorded movie. All the frames already exist on the film reel. Your consciousness is simply the projector's beam, illuminating one frame at a time, creating the illusion of a story unfolding. But if the final scene is already on the reel, was your choice in the second act ever truly free? If the future is already out there, fixed and waiting, are our decisions nothing more than an illusion? A story we tell ourselves as we glide along a predetermined track. This unsettling question forces us to confront the possibility that the one thing we feel most certain about, our ability to choose, might be the greatest illusion of all. And that leads us directly to the final piece of this puzzle, the mysterious role of consciousness itself in creating the now. Without a conscious observer, would the river of time have any banks to flow between? The ticking of a clock is a physical event, but the feeling of duration, the weight of a moment, is a private experience woven entirely within the theater of your mind. Your brain is not a passive clock. It is an active storyteller constructing the narrative of time from a chaotic stream of sensory data. It uses powerful biological rhythms, like the 24-hour circadian cycle that governs your sleep and wakefulness, to anchor this story to the planet's rotation. But the fine details, the feeling of seconds and minutes, are stitched together by complex neural processes. The neuroscientist David Eagleman describes this as a strange kind of editing, where your brain constantly takes in information, processes it, and presents you with a cohesive but slightly delayed version of the present moment. The philosopher William James called this the specious present, the short duration of which we are immediately and incessantly sensible. It is not a razor-thin line between past and future, but a small, felt expanse, the original paragon and prototype of time. This constructed present explains why time can warp so dramatically in extreme situations. In a car accident or a fall, people often report that events seem to unfold in slow motion. Eagleman's research suggests this is not because the brain speeds up, but because it switches into a high-fidelity recording mode, laying down memories with such rich detail that upon replay, the event feels like it must have taken much longer. This is your brain's storytelling mechanism in overdrive, creating a denser narrative for a moment of high importance. For some, this delicate machinery malfunctions. In time agnosia, a person loses the ability to estimate the passage of time, living in a perpetual and confusing now. The eerie feeling of déjà vu might be a small hiccup in this process, a fleeting misordering of the brain's timeline that makes the present feel like a memory. Even without a disorder, we can manipulate this sense. In deep meditation, when the constant chatter of thought quietens, minutes can feel like hours as the brain's usual markers for time's passage fade away. All of this points to a single, inescapable conclusion. The flow of time we argue about in physics might be secondary to the story our brain needs to tell to make sense of the world. Is time, then, just the most compelling story we have ever told ourselves? The smooth, continuous fabric of spacetime described by Einstein might be an approximation of a far stranger reality. A leading theory in modern physics, loop quantum gravity, proposes that space and time are not smooth and continuous at all. Instead, they are woven from a network of tiny, indivisible loops or quanta. At the most fundamental level, the universe could be digital, composed of finite grains of spacetime. As the physicist Carlo Rovelli states, time is not continuous, it is granular. This means there is a smallest possible unit of time, known as the Planck time, which is 10 to the power of negative 43 seconds. You cannot divide a second any further than this. It is the pixel of temporal reality. This theory completely upends the classical view of a flowing, river-like time. Time does not flow so much as it pulses, one discrete quantum at a time. This granular nature of reality becomes critical when we confront the most extreme objects in the cosmos, black holes. In Einstein's general relativity, the center of a black hole is a point of infinite density, a singularity where the laws of physics, including time, simply break down and cease to have any meaning. But if spacetime is granular, then this infinite curvature is impossible. There is a smallest possible size, so matter and energy cannot be compressed into an infinitely small point. The singularity is replaced by a final, ultra-dense quantum of space, a point where time, as we know it, might stop or transition into something else entirely. This is like watching a digital video on a screen. The motion looks perfectly fluid and continuous, but you know it is actually built from a rapid succession of static frames, each one a separate image. Our experience of time's smooth passage could be exactly like that, a perceptual illusion created by our brain stitching together these fundamental time quanta. This forces a profound question. If time is made of these individual chunks, what exists in the gaps between them? Is there a deeper, timeless reality between the ticks of the cosmic clock, a place where time itself is not yet real? The equations that govern our universe are written in a language that does not speak of time. At the most fundamental level, the laws of physics seem to operate perfectly well without it. Consider the pinnacle of Einstein's work, his theory of general relativity. It describes gravity as the bending of space-time, a beautiful four-dimensional tapestry. Yet the equations themselves are timeless. They do not describe a universe that is changing. They describe a universe that simply is. This timelessness becomes even more explicit with the Wheeler-DeWitt equation, a bold attempt to merge general relativity with quantum mechanics. This equation describes the entire quantum state of the universe, but it contains no time variable whatsoever. The physicist Bryce DeWitt, who developed it with John Wheeler, noted that it suggests time is not a primary feature of reality. It is something that emerges from a deeper, timeless foundation. The physicist and author Julian Barber has championed this view, arguing that time is a derived concept, not part of the deep structure of the world. In this timeless picture, the universe is not a movie. It is a single, frozen frame. But if that is true, how do we explain the undeniable feeling of change, of motion, of things happening? The answer may lie not in time, but in relationship and configuration. Imagine every single possible arrangement of every particle in the universe. This is called configuration space. In this vast, abstract landscape, every possible state of the universe exists simultaneously. There is no before or after, only a vast collection of nows. Think of it not as a single timeless photograph, but as every single photograph that could ever be taken of the universe, all existing at once in a giant, eternal album. Our conscious experience, then, is not a journey through time, but a journey through this album. We move from one configuration to a very similar one, and then to the next, creating the illusion of a continuous flow. What we perceive as the passage of time is simply our awareness moving through this landscape of static states. Change does not happen in time. Change is the relationship between these states. The universe is not evolving. It is just that different parts of it are correlated in a way that our minds interpret as a sequence. This raises a beautiful and haunting question. If the deepest laws of reality are timeless, then our relentless, inescapable experience of time's river is the most intimate and convincing illusion we will ever know. 25 centuries ago, a Greek philosopher named Parmenides gazed at the world and arrived at a conclusion so radical it still echoes in our physics today. He declared that change itself is an illusion, a mere trick of the senses, and that true reality is timeless, unchanging, and one. For Parmenides, the very notion of something coming into being or passing away was a logical impossibility. How can something come from nothing or become nothing? He argued that beneath the apparent flux of the world, there is only a single, eternal, and immutable being. This ancient idea finds a startlingly modern counterpart in physics. What if the relentless flow we call time is not a river at its own, but merely the product of change? What if time is not a fundamental stage, but a story we tell about how things in the universe move and interact relative to each other? The physicist Lee Smolin offers a compelling middle path in this debate, stating, time is real, it is not an illusion, but it might be emergent from processes of change. In this view, time is not a primary ingredient of the cosmos. It is a secondary quality that bubbles up from something more basic, from the ceaseless dance and rearrangement of the universe's fundamental components. It emerges from the evolution of quantum states, from the growth of complexity, and from the sheer fact that nothing in the universe is ever truly still. This distinction reveals a deep philosophical divide between being and becoming. Is the universe defined by its static existence, its being, as the block universe suggests? Or is it defined by its constant process of transformation, its becoming? Modern physics seems to be leaning toward a reality where being is primary, and becoming is the story we extract from it. Time, then, might simply be the name we give to the correlations between events. Think of a clock. We say its moving hands measure the passage of time. But what is really happening? The hands are just changing their position relative to the numbers on the clock's face, relative to the rotation of the Earth, and relative to your own heartbeat. The motion is real, but the time it supposedly measures is just a convenient concept we use to describe that motion and relate it to all other motion. The clock does not measure time. It participates in the universal process of change, and we use that change as a reference. This forces a deeply puzzling question. If time is nothing more than change, then what happens when all change stops? If every particle in the universe were frozen in place, would time still pass? In a world of complete and absolute stillness, would there be any now to experience? A musician on stage can become so immersed in the performance that the notes seem to play themselves. The constant internal monologue quiets, the awareness of the audience fades, and the very sense of a self separate from the music dissolves. In this state, something remarkable happens to time. An hour can feel like a single, eternal minute. This is the flow state, a psychological phenomenon documented by artists, athletes, and meditators alike, where intense focus completely alters the perception of time's passage. It is not an illusion but a different mode of consciousness, one where the brain's usual timekeeping machinery is temporarily bypassed. The mystic Eckhart Tolle points directly to this experience, urging us to realize deeply that the present moment is all you ever have. In these moments, the constructed narrative of past and future falls away, leaving only a deep, expansive now. Psychological studies on flow reveal that this state is characterized by a complete absorption in the task at hand. Self-consciousness vanishes, and with it, the anxious ticking of the mental clock. This is why a surgeon performing a complex procedure, a climber scaling a sheer rock face, or a writer lost in their story can all emerge from their focus surprised by how much clock time has actually passed. Their brains were not tracking duration because they were fully present, operating in a realm where chronological time holds little relevance. This sensation of timelessness becomes even more profound in reports from near-death experiences. Many who have been resuscitated describe a state of pure awareness, a feeling of peace and unity that exists outside of any temporal sequence. They often recount seeing their entire lives not as a linear story, but as a single, simultaneous mosaic of moments, all existing at once. These are not mere anecdotes, they are powerful, first-hand accounts that suggest our standard experience of time is just one setting on a much larger dial of consciousness. If a change in mental focus can so dramatically warp or even erase our sense of time, then the flow we feel so certain about is far more fragile and subjective than it appears. This raises a tantalizing possibility. If time is so malleable to our state of mind, could we consciously train ourselves to step outside of its current? Could we learn to live more often in that expanded present, not as a philosophical idea but as a felt reality? Our very cells beat to the rhythm of a silent clock. All life on Earth, from the tiniest bacteria to the largest whales, operates on an internal schedule meticulously tuned to the planet's 24-hour cycle of light and dark. But is this sense of time something we learn from the spinning world, or is it written into our most basic biological code? The answer lies in our circadian rhythms, intricate internal cycles that govern everything from our sleep and wakefulness to our hormone levels and body temperature. These rhythms are not just passive reactions to the sun. They are orchestrated by a complex genetic network, a molecular clock ticking away inside nearly every cell of your body. Genes with names like PER and TIM produce proteins that slowly build up during the day, only to break down at night, creating a self-sustaining feedback loop that marks the passage of time with biochemical precision. As the biologist Franz Halberg, who coined the term circadian, once noted, the timing of life is as crucial as the events themselves. This internal mechanism is so robust that if you were to place a person in a deep cave, completely isolated from all external light and time cues, their body would continue to cycle for weeks. Their sleep, their temperature, their alertness would all still rise and fall, guided by that innate internal rhythm. This proves that biology does not merely respond to time. It generates its own, but the story of biological time goes far deeper than a 24-hour cycle. Different creatures experience the flow of moments at wildly different rates. To a common fly, the world must appear to move in slow motion. Its much faster metabolic rate allows it to process visual information at a higher frame rate, meaning it can react to threats in what would seem to us like a fraction of an instant. A rolled-up newspaper moves through the air like a sluggish balloon to a fly, giving it ample time to escape. On the opposite end of the spectrum, consider an animal in hibernation. Its heart rate plummets, its body temperature drops, and its metabolism slows to a crawl. For months, it exists in a state of suspended animation. Does time for that bear or ground squirrel feel like it has slowed down? Does it emerge from its long sleep feeling as if only a day has passed, while the outside world has moved through an entire season? These biological clocks are masterful adaptations, finely honed by evolution to help us survive in a rhythmic world, but they force a profound question. Is our biological time just a useful tool, a clever trick to sync up with the planet? Or does the fact that life itself creates and perceives time point to something far more fundamental, a deep connection between biology and the very physics of reality we have been exploring? This classic thought experiment violently rips apart our intuitive sense of cause and effect. If you were to travel back in time and prevent your own grandfather from meeting your grandmother, you would ensure your own birth never happens. But if you were never born, how could you have traveled back in time to commit the act in the first place? This is the grandfather paradox, a logical knot that seems to make time travel an impossible fantasy. Yet the laws of physics, as we currently understand them, do not explicitly forbid it. In fact, Einstein's equations of general relativity actually provide a blueprint for how it might be achieved. The theory allows for the existence of structures called closed time-like curves, which are essentially paths through the fabric of space-time that loop back on themselves. An object following such a path would eventually return to its own past. The most plausible place to find these curves is in the extreme gravity well around a rotating black hole, or within a theoretical construct of exotic matter known as a wormhole. The renowned physicist Kip Thorne, who worked on the scientific concepts for the film Interstellar, has stated that time machines are not forbidden by the laws of physics. So how do we resolve the paradox? One compelling solution is the self-consistency principle, which asserts that the timeline is rigid and any actions you take in the past were always a part of that timeline. You would find it physically impossible to kill your grandfather. The gun would jam, you would miss, or some other event would conspire to ensure history unfolded exactly as it always did. Your trip to the past was always a part of your own history. Another solution comes from the many worlds interpretation of quantum mechanics. In this view, the moment you arrive in the past, you cause the universe to branch into a new parallel timeline. You could indeed alter events in this new reality, but you would not be affecting your own original past. You would simply be creating a new future, a new branch on the tree of reality where you may or may not exist. This is what makes the grandfather paradox so deeply unsettling. It forces us to question the very nature of causality and free will. If the past is fixed and cannot be changed, as the self-consistency principle suggests, then were your actions ever truly free? Or were you just playing a preordained role in a cosmic script, your illusion of choice nothing more than a performance for an audience of one? The possibility of time travel, even in theory, suggests that time might be a real, physical dimension we can navigate, not just a story we tell. But if that is true, it leads us to an even more fundamental mystery about the nature of reality itself. McTaggart's argument exposes a deep logical flaw in our very concept of time. He identified two ways we order events. The A series places them as past, present, or future, a flowing, changing status. The B series simply orders them using permanent relations like before and after. McTaggart argued the A series is essential for time to feel like it's passing, but it is also fatally contradictory. How can a single event be future, then present, then past? This change requires a second time dimension to measure the change in the first, which then requires a third, leading to an infinite and absurd regression. He concluded that because this flow is contradictory and time requires this flow, time itself must be unreal. This is not just wordplay. It suggests the relentless passage of moments is a fundamental illusion woven into the fabric of our perception. Centuries earlier, the philosopher Immanuel Kant arrived at a similarly startling conclusion from a different angle. He proposed that time is not an empirical concept derived from experience, but a necessary representation that grounds all intuitions. For Kant, time is not something we discover out in the world. It is the very lens through which we see the world, a fundamental framework of the human mind that we automatically impose on all our experiences. We cannot help but see reality in terms of before and after, cause and effect, because that is how our consciousness operates. It is the operating system of perception, not a feature of the external universe. This view finds a powerful echo in the realm of timeless truths. Consider the number 2, or the equation 2 + 2 = 4. These are not things that came into existence with the Big Bang. They were not created and they cannot be destroyed. They are simply and eternally true regardless of any point in time in any possible universe. A circle will always be defined as the set of points equidistant from a center. This is a truth that exists outside of time, a fixed point in a seemingly fluid reality. If such fundamental truths are timeless, what does that say about the stage they are presented on? It forces us to ask a deeply personal and unsettling question. If time is not a real, fundamental feature of the cosmos, but rather a framework we impose or an illusion we experience, why does it feel so incredibly vivid, so urgent, and so inescapable? The answer may lie not in the nature of time, but in the mysterious intersection of physics and the conscious mind. Every action you take, every memory you form, is a transaction in a cosmic economy of information. This deep connection between time, disorder, and information reveals a startling new layer to the arrow of time. We already know entropy tends to increase, but why? The answer may lie in the fundamental nature of information itself. In 1961, physicist Rolf Landauer made a profound discovery. He realized that information is not an abstract concept. It is physical. Every bit of data, whether stored in your brain, on your phone, or in the universe itself, has a physical form. Landauer's principle states that erasing information is not free. It always generates a tiny amount of heat, which increases the entropy of the surrounding environment. Think about your computer's hard drive. When you delete a file, the machine must reset those tiny magnetic bits to zero. That physical act of erasure requires energy and releases heat into the room. The information is gone, but the universe's disorder has increased. This provides a direct physical mechanism for the arrow of time. The flow of time may be inextricably linked to the processing and inevitable erasure of information. As the physicist Seth Lloyd suggests, the universe is a quantum computer, and time is how it keeps track of changes. In this view, the cosmos is not just a collection of particles, it is a vast, ongoing computation. The evolution of the universe from the Big Bang to the present is a calculation, with each interaction processing information. Time, then, might simply be our experience of this cosmic computation unfolding. This leads to one of the most intense debates in modern physics, centered on the ultimate information erasers, black holes. According to quantum mechanics, information can never truly be destroyed. It can be scrambled, but it must be preserved. Yet, a black hole appears to violate this sacred law. Anything that falls in, including all the information that described it, seems to be lost forever when the black hole eventually evaporates through Hawking radiation. This is the black hole information paradox, a crisis that pits quantum theory against general relativity. If black holes do destroy information, it would mean the fundamental laws of physics are not reversible, and our understanding of time's arrow is incomplete. The resolution to this paradox might be that the information is not lost but is somehow encoded on the surface of the black hole's event horizon, a holographic imprint of everything that fell in. This suggests that the flow of time and information are two sides of the same coin, woven into the fabric of space-time itself, so we are left with a breathtaking question. Is the relentless passage of time, the feeling of seconds slipping away, nothing more than the universe processing an unimaginable amount of data? These strange structures do not repeat in space like a diamond or a snowflake. They repeat in time. A time crystal is a quantum system that oscillates, ticks, if you will, perpetually without any energy input. It is a clock that winds itself forever. The Nobel laureate Frank Wilczek, who first theorized their existence, described them as a new form of order that breaks time translation symmetry. This means the crystal state is not the same at every point in time, even in its ground state, its lowest energy configuration. It possesses a rhythm that the featureless vacuum of empty space does not. Creating one is a feat of modern alchemy. Scientists use precise lasers to trap and manipulate a ring of ions, putting them into a coherent quantum state. Then, with a carefully tuned microwave pulse, they nudge the system, and it begins to tick, flipping between two states with a regular, unchanging period. This is not perpetual motion in the classical sense, which is forbidden by thermodynamics, because the crystal is not doing work or outputting energy. It is more like a quantum drum that, once struck, never, ever stops vibrating. The potential is staggering. This flawless, self-sustaining rhythm could be the heartbeat of a new generation of quantum computers, providing a stable clock for incredibly complex calculations. But the deeper implication is philosophical. If we can create matter that has an inherent, immutable rhythm woven into its very fabric, does that make time itself more real? Does it suggest that time is not just an emergent property, but a fundamental stage upon which even the most exotic quantum phenomena must play out? Or does it simply mean that within the timeless equations of quantum physics, there exist solutions that dance, solutions that have rhythm built into their core? The existence of time crystals does not yet answer whether time is an illusion, but it profoundly changes the question. It proves that temporal order is a property that matter itself can possess. This discovery makes the dream of a time machine feel less like fantasy and more like a future engineering problem, waiting for a mind brilliant enough to solve it. The way we perceive time is not a universal human constant but a deeply cultural artifact. Western societies often view time as a linear arrow, a straight path from the past through the present and into a future we are constantly striving toward. This perspective fuels our goal-oriented nature, our emphasis on progress, and our constant race against the clock. In stark contrast, many Eastern philosophies, like those found in Hinduism and Buddhism, perceive time as a great wheel, a cyclical process of creation, preservation, and destruction. In this view, the universe breathes in and out over eons, with no true beginning or end, only an eternal return. As the anthropologist Edward Hall observed, time is one of the fundamental bases on which all cultures rest and around which all activities revolve. This foundational difference shapes everything from religious beliefs to daily routines. The linear model creates a sense of urgency and a focus on legacy, while the cyclical model fosters acceptance, reincarnation, and a focus on the recurring patterns of life. But the variations go even deeper than this broad division. Consider the Aymara people of the Andes, whose language and gestures reveal a completely inverted spatial metaphor for time. For the Aymara, the past is known and visible, so it lies ahead of you where you can see it. The future, however, is unknown and unseen, so it lies behind you, out of view. When speaking of a past event, an Aymara speaker might gesture forward, and when discussing the future, they might point over their shoulder. This is a profound reversal of the common metaphor where we look forward to the future and leave the past behind. These deeply ingrained cultural models lead to tangible differences in how we live. A culture with a linear, future-oriented view often has a strict adherence to punctuality, detailed long-term planning, and a tendency to view time as a resource that can be saved, spent, or wasted. A more present-oriented or past-oriented culture might place a higher value on relational time, on events starting when everyone has arrived rather than at a predetermined minute, and on a deep connection to history and tradition. This is not about one being right and the other wrong, but about different ways of being in time. This cultural lens even affects our collective imagination. The Long Now Foundation is building a clock designed to run for 10,000 years, a monumental project intended to foster long-term responsibility and thinking on a scale that dwarfs our usual quarterly reports or 5-year plans. It is a physical attempt to break free from our short-term cultural programming and embrace a deeper, almost geological sense of time. All of this forces a critical question. If our experience of time can be so malleable, so deeply shaped by the culture we are born into, how much of it is an inherent part of reality, and how much is a story we have collectively agreed to tell? The physics suggests a timeless foundation, while our biology provides a rhythm, but our culture writes the narrative, the script we use to navigate our lives from one moment to the next. The satellite guiding your drive to the grocery store is living a different reality than you are. The global positioning system is a daily, working proof that time dilation is not just a theory but a practical engineering challenge. Each of those satellites orbiting high above the Earth experiences time slightly faster than we do on the surface. They are both moving at tremendous speeds, which according to special relativity makes their clocks tick slower, and they are farther from Earth's gravitational pull, which according to general relativity makes their clocks tick faster. For GPS, the gravity effect wins. If the sophisticated atomic clocks aboard these satellites were not constantly corrected for this difference, the entire system would become useless in a matter of hours, and your navigation app would guide you into a field instead of a parking lot. As physicist Brian Greene states, time dilation is not science fiction, it is engineering reality. The math behind it is elegant. The faster you move through space, the slower you move through time relative to someone watching you. The deeper you sit in a gravitational well like Earth, the slower your clock ticks compared to someone floating in space. We can even see this with particles from space called muons. They are created when cosmic rays hit the upper atmosphere, and they decay so quickly that they should never reach the ground. But because they are traveling at nearly the speed of light, their internal clocks slow down dramatically from our perspective. Their lifetime stretches out just long enough for them to shower down upon us, passing through our bodies as silent, invisible evidence of relativity at work. This was confirmed with stunning precision in the 1970s when scientists flew incredibly accurate atomic clocks on commercial airplanes. After the flights, these clocks were compared to identical clocks that had remained on the ground. The traveling clocks were found to be ever so slightly behind, a tiny fraction of a second lost to the sky, exactly as Einstein's equations predicted. So we are left with a disorienting truth. The device in your pocket works because physicists had to accept that there is no single, universal clock for the universe. Your now and a satellite's now are out of sync. If time itself can stretch and compress based on motion and gravity, then what does it even mean for two events to happen at the same time? The ultimate fate of our universe may be a state of perfect, unchanging order. In the far future, trillions of years from now, the cosmos could reach its final equilibrium. Every star will have burned out, every black hole will have evaporated, and all matter will be evenly distributed across an ever-expanding, near-perfect vacuum. This is the heat death, the point of maximum entropy where no energy gradients remain to be exploited. There will be no more stars to form, no more chemical reactions to power life, not even a single gust of wind. As physicist Lawrence Krauss describes it, the universe will become a cold, dark, and timeless void. In this state of absolute stillness, where no change of any kind is possible, the very concept of time loses all meaning. There is no before or after because nothing ever happens. It is the final, frozen tick of the cosmic clock, but this is not the only possible end. Some theories suggest a far more violent finale. The Big Rip scenario proposes that the mysterious force known as dark energy could become so dominant that it overwhelms all other forces in the universe. It would first tear apart galaxy clusters, then solar systems, then planets, and finally, it would rip apart atoms and the very fabric of space-time itself. In this cataclysm, time would not fade away, it would be shredded into non-existence. Another abrupt end could come from vacuum decay, where a bubble of true vacuum, a more stable state of reality, spontaneously forms somewhere in the universe and expands at the speed of light. Everything it touches, including the laws of physics and the dimension of time itself, would be instantly rewritten. You would not see it coming, and in an instant, time would simply cease to be. These dramatic endings find a quieter counterpart in the equations of quantum cosmology. The Wheeler-DeWitt equation, which describes the entire quantum state of the universe, famously contains no time variable. It suggests a static reality, a single, frozen moment that just is. The wave function of the universe does not evolve or change, it simply exists eternally. Think of it like a wind-up toy that has finally, completely run down. The springs are slack, the gears are motionless, the potential for movement is gone, and all that remains is a silent, static object. If this is the ultimate nature of reality, then the flow of time we experience is not a fundamental river, but a temporary eddy, a local fluctuation in a timeless ocean. This forces a deeply unsettling question. If time can have a beginning and can truly, meaningfully end, was it ever a fundamental part of the cosmos to begin with, or was it merely a temporary phase, an emergent property of a universe transitioning from one state of nothingness to another? The concept of absolute nothingness may be the greatest illusion of all. We picture a perfect, empty void, but physics paints a far stranger picture. Even in what we call a vacuum at the tiniest scales, reality is a seething foam of potential. Particles and their antiparticles constantly flicker into existence, borrowing energy from nowhere before annihilating each other and vanishing, all within a time so short it is almost impossible to conceive. This quantum fluctuation is not a theory. We can observe its effects in the lab. So what if our entire universe is just one of these fluctuations, but on a cosmic scale? A single, stable bubble that refused to pop. Stephen Hawking captured this breathtaking idea, stating, "Because there is a law like gravity, the universe can and will create itself from nothing." In this view, the law of gravity is the ultimate free lunch ticket, a rule that allows something to emerge from what we mistakenly call nothing. This quantum nothing is not an empty stage waiting for a play to begin. It is a dynamic, restless sea of possibilities, and time itself may have crystallized out of this chaos. This leads to proposals like the no-boundary hypothesis, where the universe has no distinct beginning point in time. Imagine the North Pole on a globe. There is no point north of it. In the same way, the Big Bang might not be a creation from nothing, but a smooth, curved transition from a timeless state, where the dimension of time gently emerges like a latitude line. Other theories suggest a cyclic model, a cosmic heartbeat where universes are born from collisions in a higher dimensional space, expand, contract, and are reborn again in an endless cycle with no true start or finish. Think of it like a bubble forming in a pot of boiling water. It swells, rises to the surface, and pops. Our universe is that bubble, but the boiling water, the greater multiverse, is eternal and timeless, constantly generating new bubbles, each with its own internal clock that begins ticking the moment it forms. This makes us wonder, is our experience of time from the first second to the last merely a local phenomenon, a temporary phase within our particular cosmic bubble? If so, then the multiverse could be a symphony of times, each universe marching to the beat of its own drum, completely unaware of the timeless silence from which it came. The universe refuses to choose a single story. According to the many worlds interpretation of quantum mechanics, every single quantum event that has multiple possible outcomes does not settle on just one. Instead, the entire universe splits, with each possibility playing out in its own newly created branch. A single electron's spin, a radioactive atom's decay, the firing of a single neuron in your brain that leads to a decision. All of these are moments where reality fractures. As physicist Hugh Everett proposed, the universe is constantly splitting into a multitude of realities. This is not a theory of multiple universes existing far away in space, but of an endlessly branching tree of time, where every possible version of history is real. In this view, the grandfather paradox is neatly sidestepped. You can travel to the past, and anything you do there simply creates a new, parallel timeline. You might indeed prevent your own birth, but only in that new branch of reality, leaving your original timeline and your own history completely untouched. This means every choice you have ever made and every choice you will ever make is being made. In another branch, a version of you took the other job, said yes instead of no, or left the house 5 minutes earlier. All possibilities are realized, each in its own world. This has a profound implication for the nature of time itself. Each of these branching timelines has its own arrow of time, its own flow from a shared past toward a divergent future. But the multiverse as a whole, this incomprehensibly vast ensemble of all possible realities, might itself be timeless. It just is, a static, eternal structure containing every moment that ever could be, like a library that holds not just every book ever written, but every book that could possibly be written. This forces a dizzying question about our own identity. If there are infinite versions of you living out every permutation of your life, are you truly an individual, or are you just one thread in a vast tapestry of selves? The film Everything Everywhere All at Once gave us a powerful, human-scale glimpse of this idea, where a single woman accesses the skills and memories of her alternate lives, realizing that every disappointment and every triumph is being lived by another her in another world. If this view is correct, then the concept of now becomes almost impossibly vast. Your present moment is just one now in an infinite sea of nows, all equally real. What, then, is so special about the one you are currently experiencing? Your brain is constantly editing the film of your life to create a seamless experience of the present. Light, sound, and touch all travel to your senses at different speeds, and your brain receives and processes this information at different rates. To prevent your reality from becoming a chaotic jumble of out-of-sync signals, your brain performs a remarkable feat of synchronization. It actively works to align these disparate inputs, stitching them together into what you perceive as a single, coherent moment. This is why when you watch a drummer strike a snare, you see the stick hit the skin and hear the crack at the exact same instant, even though the sound waves took slightly longer to reach your ears than the light waves took to reach your eyes. Your brain waits for the slowest information to arrive, holding the visual data in a buffer until the auditory data catches up, and then presents it to your consciousness as a unified event. This editing happens within what neuroscientists call the temporal window of integration, a period of about 2 to 3 seconds where events are bundled together and perceived as happening now. This window is the psychological seat of the present moment, the duration we feel we are directly experiencing. But this necessary delay means you are never truly experiencing the present as it happens. You are always living in the very recent past, your consciousness a beautifully crafted delay of the real world. This neural editing is so sophisticated that it often predicts the future to perfect the present. As neuroscientist Dean Buonamano noted, the brain is a time machine. It uses its knowledge of the past to anticipate what will happen next, effectively closing the gap between an event and your perception of it. We can see this prediction in action with illusions like the flash lag effect. If a light flash occurs at the exact same position as a moving object, you will perceive the flash as lagging behind the object. Your brain has already predicted the object's future location, and it adjusts your perception to match that prediction, making the world seem smoother and more stable than it actually is. So if the present moment is not a direct experience but a carefully constructed story, a best guess assembled from delayed and predicted signals, how real is the now we feel so certain of? A self-driving car does not feel the rush of moments as it navigates a busy street. It processes a relentless stream of discrete data points, snapshots of the world captured by its sensors. For artificial intelligence, time is not a flowing river of experience, but a sequence of time-stamped events to be analyzed. These systems operate on the principle of correlation, not causation, finding patterns in sequences without any innate understanding of before and after. The pioneering AI researcher Julia Pearl pinpointed this fundamental gap, noting that causality is the foundation of reasoning about time, but machines struggle with it. An AI can learn that a dark cloud is often followed by rain, but it does not grasp the physical cause, the idea that the cloud actually produces the rain. To simulate a sense of temporal flow, engineers design specific architectures like recurrent neural networks. These networks contain loops that allow information to persist, creating a kind of digital short-term memory. This lets the model use data from previous steps in the sequence to inform its next prediction, which is crucial for tasks like translating languages or predicting the next word you will type. The system is not remembering a past moment as we do. It is simply weighting the current input based on a mathematical representation of what came before. In this way, the AI constructs a functional yet entirely hollow version of temporal awareness. It is a brilliant mimic, a clock that tells time without understanding the concept of hours or minutes. This artificial perception of sequence is what allows our autonomous vehicle to not just see a pedestrian, but to forecast their future position on the road, calculating trajectories from a series of isolated points in time. This capability forces a profound question upon us. If a machine can so effectively model and navigate a time-based world using pure computation, does that suggest time itself is at its heart a kind of information processing? The idea that our universe is fundamentally computational, a notion explored in digital physics, suddenly feels less like science fiction and more like a legitimate and deeply unsettling possibility. Digital physics proposes a startling hypothesis that the universe is not just described by mathematics, but is literally a computational system. In this view, the fabric of spacetime is not smooth and continuous, but a vast, discrete lattice of bits, like the pixels on an impossibly high-resolution screen. And what is time in this digital cosmos? It is simply the sequential processing of information, the universe computing its own next state, one Planck time after another. The physicist John Archibald Wheeler captured this radical idea with his famous phrase, "it from bit." He suggested that every particle, every force, and every event in the cosmos ultimately derives its existence from the answers to yes or no questions, from bits of information. Reality is not made of stuff, it is made of information. This perspective completely redefines time. It is no longer a mysterious river flowing from past to future. It is the clock cycle of the cosmic computer, the relentless iteration of a fundamental program. We can see a beautiful, simplified version of this in action with something like Conway's Game of Life. This is a cellular automaton, a digital universe on a grid. It starts with a simple configuration of cells, either on or off, and then follows a set of basic rules. A live cell with too many neighbors dies. A dead cell with the right number comes to life. From these incredibly simple, timeless rules, an astonishing complexity emerges over many iterations. Gliders soar across the grid, patterns replicate themselves, and entire civilizations of pixels are born, live, and die, all from the step-by-step execution of a code. This is not a metaphor for time, it is a direct analogy. Each tick of the clock advances the entire grid to its next state, just as each Planck time might advance our universe. Now think of a modern video game. You are exploring a vast, open world that feels continuous and real. But under the hood, the game engine is rendering individual frames, calculating physics, and processing your inputs one discrete step at a time. Your experience of a fluid, dynamic world is an emergent illusion created by the rapid processing of the hardware. Could our reality be the same? Is the relentless flow of moments just our conscious experience of the universe rendering its next frame? This leads us directly to the simulation hypothesis. the idea that our universe might be an artificial construct, a simulation running on some unfathomable computer in a base reality. And if that is true, then time is not a fundamental feature of the cosmos. It is a feature of the processor, the rate at which the simulation is being run. This is not just a whimsical thought experiment. It forces profound ethical questions about the nature of our existence and the meaning we assign to our fleeting lives within the program. If time is not a fundamental river but a convincing story, how then should we navigate our lives? The ancient philosophy of Stoicism offers a powerful and practical answer, one that resonates deeply with this modern physics. The Roman Emperor Marcus Aurelius, meditating in his tent nearly 2,000 years ago, wrote, "Confine yourself to the present." He advised focusing your energy not on a future you cannot control or a past you cannot change, but on the only moment you truly ever have access to, the now. This is not a call to abandon responsibility, but to anchor your actions in the immediate reality before you. If the future is not a real place waiting for us, but is instead being built from the decisions we make in each successive present moment, then our power and our duty exist entirely in the here and now. Understanding time's potential illusion can be a profound liberation from anxiety and regret. Worry about the future is a story we tell ourselves about a reality that does not yet and may never exist. Regret is a story we tell about a past that is frozen and unchangeable in the block universe. By seeing these as mental constructs rather than absolute truths, we can loosen their grip on our well-being. This does not mean we stop planning or cease to learn from history. We must still act as if time matters because our biological and social lives operate within its flow. We set alarms, meet deadlines, and save for retirement, but we can do so with a lighter heart, appreciating the deeper mystery that underlies our daily schedules. Astronauts experience a version of this shift in perception, known as the overview effect. From the vantage point of orbit, seeing the Earth as a fragile, borderless blue marble against the black void of space, their sense of time and scale is dramatically altered. Petty conflicts and personal anxieties seem to shrink against the cosmic backdrop. They report feeling a profound connection to the present and to the planet as a whole. If every second is an illusion, then the way we make them count is not by frantically trying to accumulate more of them, but by investing the one we are in with our full attention and intention. The value of a moment is not measured by its duration, but by the depth of our engagement with it. William James once observed that our greatest weapon against stress is the ability to choose one thought over another. This insight becomes profoundly empowering when we consider time's illusory nature. If the relentless flow of seconds is not an absolute feature of reality, but a construct, we can learn to loosen its grip on our well-being. This begins with mindfulness, the simple practice of anchoring your awareness in the sensations of the present moment. When you feel anxious about a future deadline or regretful about a past mistake, gently guide your focus back to your breath or the physical world around you. This is not an escape from responsibility, but a way to engage with your life from a place of calm, rather than from a frantic race against an unseen clock. You can actively design your days to honor time's fluidity. Carve out periods for deep, immersive work where you intentionally disconnect from clocks and notifications, allowing yourself to enter a state of flow where chronological time loses its meaning. Similarly, schedule moments of pure relaxation without a fixed end time, giving yourself permission to simply be rather than to constantly do. Reflecting on your priorities through the lens of eternity can be a powerful, clarifying exercise. Ask yourself, if all of time exists at once, what are the moments that truly define my story? This perspective shrinks daily irritations and amplifies what is genuinely meaningful, guiding you to invest your energy in relationships and projects that resonate with your deepest values. Embrace flexibility in your plans, understanding that a rigid attachment to a specific timeline is often a source of frustration. By accepting that the universe does not adhere to our schedules, we can respond to delays and changes with creativity and grace instead of stress. Experiment with perceiving time differently. Spend an afternoon walking in an old-growth forest where the slow growth of trees and the patient turn of seasons can recalibrate your internal rhythm. Try a meditation focused on the breath, observing the subtle space between each inhalation and exhalation. These practices can offer a direct, personal glimpse into the possibility that the now is wider and deeper than we ordinarily perceive. The journey through physics and philosophy is not meant to diminish the preciousness of our moments, but to enrich them. By understanding that time may be a story, we are freed to become better authors of our own lives, writing each chapter with more intention, less anxiety, and a greater sense of wonder. From the stretching of time in Relativity to the ghostly superimpositions of quantum mechanics, our journey reveals a cosmos where time is not a fundamental river but a story that emerges. We have seen how our own brains stitch together a seamless present from discrete moments, and how cultures weave entirely different narratives from the same cosmic raw material. Physics presents a compelling case that the relentless tick of the clock is a powerful, useful, and deeply convincing illusion. This perspective is not a cold, scientific dismissal of our experience, but a profound liberation. Understanding that time may be a construct can free us from being slaves to the clock, opening us to a deeper, more mindful appreciation of the only moment we ever truly have. As the physicist Carlo Rovelli so elegantly states, time is ignorance. It is the name we give to the gap in our understanding of a timeless, interconnected reality. We would love to hear your thoughts on the nature of time in the comments below, and if you enjoyed this exploration, please subscribe for more mind-expanding content on the mysteries of our universe. The greatest mystery may not be waiting in some distant galaxy, but in every single, seemingly ordinary second we think we know.